number 33, we're dealing with a system of equations. The first thing that we need to do is define our variables. Let's let x equal the cost of hamburgers. Y will equal the cost of cheeseburgers. And z will equal the cost of berry burgers. Now, how did I know that x, y, and z represented the costs? If you read through the problem, it tells us how many, and it tells us the total cost. And the very last question says determine the cost of each type of burger. This is what tells us what exactly we're looking for and what our unknowns are. In Part A, it asks us to write a system of equations that represents the problem. Reading through the problem, the equations are very easy to write. It says that Jill and her friends visited 3 times. We're going to write one equation for each visit. One equation for each visit. The first time, they got 3 hamburgers, 5 cheeseburgers, and 6 berry burgers for a total cost of $25.24. The second time, they got 2 hamburgers, 7 cheeseburgers, and 5 berry burgers for a total cost of $25.68. And the third time, they got 4 hamburgers, 4 cheeseburgers, and 7 berry burgers at a cost of $26.59. This is our system of equations. In Part B, we're asked to represent this system as a matrix equation. In order to do this, we will first have a coefficient matrix, which takes all of the coefficients out of each of the first 3 equations in order and in their place. 3, 5, 6, 2, 7, 5, 4, 4, 7. These coefficients would need to be multiplied by the variable matrix, which contains the variables x, y, and z. In our last matrix, we're also going to have a 3-by-1 matrix, with the total costs inside. Now, let's just review these matrices. The first one is the coefficient matrix. The second one is the variable matrix. And the final one has our total costs. The first matrix is 3 by 3. The second matrix is 3 by 1. Therefore, we expect the resulting matrix to also be 3 by 1. In order to determine the cost of each type of burger, we now need to solve this matrix equation. I'm going to write a representation of this process. I'm going to call my first matrix, the coefficient matrix, the matrix A. My variable matrix I'm calling X. And my cost matrix I'm calling B. So our matrix equation is represented by A times X equals B. In order to solve any equation, we always have to isolate X. A matrix equation is no different. In order to isolate X, we are going to left multiply each side of the matrix by A inverse. Remember that A inverse times A produces the identity matrix. Then the identity matrix times any matrix is the matrix itself. This shows us that we can find the answer to our question, the X matrix or the variable matrix, by multiplying the inverse of the A matrix by the B matrix or the cost matrix. We can do this in our calculator. Enter the original A matrix by doing second matrix, edit, and choose the A matrix. You'll then have to enter 3, enter, 3, enter to give the size, and then you'll be able to enter each of the coefficients. You need to do the same thing with the B matrix, but first you'll need to do second quit to get out of matrix A. Remember your B matrix is 3 by 1. Enter those values. Second quit to get out of the B matrix. At this point, you can pull up the A matrix with second matrix name and hit A. Second matrix, and under names, hit number 1 or A. We're then going to use the inverse key, which looks like x to the negative 1. It is the same key as the matrix key was, but without hitting second first. And then we'll hit second matrix again, and under names, pull up the B matrix. When we hit enter, we will get our answer, X. In this case, the X matrix, or X, Y, Z, comes out as 85 cents for a hamburger, $1.79 for a cheeseburger, and $2.29 for a berry burger. Remember, for a word problem, it's always best to answer the question in full sentences when you're finished with the whole problem.